In this video, we're going to deploy a sample Kubernetes application that will demonstrate how Tanzu Services provides both storage and networking capabilities to developers, all consumed through native Kubernetes interfaces. For storage, we will demonstrate this by provisioning a persistent volume claim, which is how developers will request storage for their persistent applications. On the networking front, developers will be able to request a load balancer that is automatically provisioned by NSXT running within VMware Cloud on AWS. For demo simplicity, we are going to disable the default pod security policy. This is purely for demo purposes. Next, we're going to create a Kubernetes namespace. We'll call this demo. To consume storage in Kubernetes, we will create a request for a persistent volume claim or a PVC. In this example, we're going to call it mongo-storage. We also have some metadata labels that give some additional information about this request. We'll also be using the default VM storage policies, and for this particular volume, it will be an 8 GB request. We'll go ahead and create the PVC request by running kubectl apply -f and providing the YAML manifest. We can get progress on our PVC request by doing a kubectl get PVC and specifying our namespace, which is demo, to see the progress of our volume. As you can see here, the volume has already been bounded and it's currently consuming our storage class as we expected. As a reminder, you can get the available storage classes by doing kubectl get sc, and here we can see our storage class that we're using. Let's now switch over to the vSphere UI and see what our cloud administrator can view from the storage request. If we navigate over to the vSphere cluster under the Monitor tab, you'll see a Cloud Native Storage tab. Under that, there is a Container Volumes. As you can see, the storage that has been requested by the developer, we now have visibility within the vSphere UI for the cloud administrator, including Kubernetes metadata that we had shown you earlier. We can see here's the 8 GB volume that has been provisioned as a first-class disk. When we expand the more information, we get much more detail, such as the vSphere namespace that's consuming the storage, the underlying TKC that has this PVC mounted. We also get information about the PVC claim, such as the additional name and label as shown earlier. This makes debugging and troubleshooting extremely easy while giving developers the ability to self-service. Now we're going to deploy our demo application, which is a Node.js web application. We first deploy our deployment by running kubectl apply and specifying our deployment manifest. Next, we're going to check the status by doing a kubectl get deploy /demo and specifying our demo namespace, and we can see that our deployment is already running. We can also check the progress by ensuring that the pod is running by doing a kubectl get pods, again specifying our demo namespace, and here we can see our demo application is running along with our Mongo database. Next, we want to expose this application so we can connect to it externally. We're going to do so by requesting a Kubernetes service of type load balancer. And here we're going to map port 80 to the target port of our application, which is running on 8080. And again, this is going to map to our demo application. To request a load balancer for your application, all the developer needs to do is to apply this YAML manifest, and automatically the NSX integration as part of Tanzu Services will request an allocated IP address out of the egress CIDR that was configured earlier in the infrastructure. To get progress on the load balancer request, simply run kubectl get svc specifying the demo namespace. Here we can see the IP address for the load balancer has been allocated by NSXT. We can confirm that this is functional now by simply doing a basic curl to this IP address, and we can see that our application is responding. This is great if you want to access your application internally, but what about exposing this to the external web, such as the public internet? Using Tanzu Services from VMware Cloud, this is extremely easy. We first off go to the Network and Security tab of our SDDC, and we request a new public IP address. Once the public IP has been allocated, we're now going to navigate over to the NAT configuration, and we're going to create a NAT rule that's going to translate our internal address to a public IP address that we've just allocated, in this case 172.30.2.4, which is running our application. Once this is configured, we can now open a browser and we should be able to access our application. As you can see, our application is now available over the public internet and our developer is probably pretty happy. This is all thanks to Tanzu services on VMware Cloud and AWS.